In this session, we will discuss about vector data. Vector data represent the real-world features within the GIS environment. Features are anything we can see on the landscape like houses, roads, trees, rivers, and so on. And these vector data or features have attributes which consist of text or numerical informations that describe the features. Vector data is classified into three: point, line, and polygon. That means you can represent the earth features by using point, line, and polygons. Now we will learn how to create a vector layer in QGIS. For that we have to go back to the QGIS. To create vector data, we need a base map. For that we will use our projected topo sheet as base map. First, we will open our projected topo sheet from our data source manager window. Now we will digitize the features from this topo sheet and will save as vector layers. To create the vector file, go to the layer menu, click on create layer followed by new shapefile layer. From this window, click on the browse button to specify the locations where you want to save your vector data. In my case, I am saving the file into desktop QGIS training where I saved all my georeference and projected topo sheets. Enter the name of your vector file data. I am giving the name as imp_cities, as I am going to digitize the important cities on the topo sheet using point vector data. The extension of this vector file is called shapefile. We will talk about it later. Click on save. Keep the file encoding as default. Click on the geometry tab. As we can see the different type of geometries that we are already discussed before. Click on point as we are going to create a point vector file. Click on select CRS button to specify the coordinate reference system. Type in the filter bar as WGS84 UTM zone 43. As we can see that there are two types of coordinates, WGS84 UTM zone 43 north and 43 south. We already discussed about the northern and southern hemisphere in the same zone, as India is coming under the northern hemisphere and Kerala is falling under zone 43. Select the WGS84 UTM zone 43. Click on OK. Our topo sheet is already projected with the UTM zone 43 north coordinate systems. That is the reason why we are using the same coordinate system into our vector data. It is very important to remind that all the data which we use in a particular project should be in same coordinate reference system. As we already discussed that we can store the information of a features into the attribute table of a vector data. For that we have to create a field in the attribute table. Now we are going to create a field in the attribute table. Here I will enter C_name as field name. This is the short form of city name because only 10 letter is allowed as field name. Also the field name should not contain any white space. That is the reason why I use the hyphen. Click on the type drop down menu. Here we can see the different format. This indicates what type of data you are adding into the attribute table. Using text data format, we can use alphabets, special characters, and both alphabets and numerics. In whole number, we can only use numerics. In decimal number, it allows to enter decimal points. Date format is used to store the date information. Now I will select the text data for city name. Commonly we are using the text data as a format because it can store numerics as well as special characters and a mixture of both. But if you want to do some quantitative calculations, the field format should be in numerics. That means whole number or decimal numbers. And this length is used to specify the total character of feature informations. That means if you give the length as 4, we can't add more than 4 characters. So I will enter here 30. That means I am using the CNAME as a field name to store the city names from the topo sheets. I know the city name won't be greater than 30 characters. Click on add to field list. Now we can see that the entered information is added into the field list. Also we can see that one more field is added into this field list. It is the system generated field. If we want to keep, we can leave as it. Otherwise we can remove it by selecting the field list followed by clicking on the remove list. Here I am not going to remove the ID field. I will keep as it. If you want to add more fields, you can create by adding the informations here followed by click on add to field list. Now click on OK to create an empty vector file. Now the vector data is added into our layer panel. Now we can check the attribute table of our vector data by right click on the layer. Click on open attribute table. Here we can see the empty attribute table with the 2 field or columns which were added while creating the data file. Which were added while creating the vector data. Now we need to add the features by digitizing our topo sheet. To digitize the features, we need to add the digitizing toolbar. We can add the digitizing toolbar by right click on the empty space followed by check the digitizing toolbar. Now zoom to the place where we want to digitize. As I am going to digitize the city name, I need to find the city name from the topo sheet. To digitize, select the point layer from the layer panel. Go to the digitizing toolbar. Click on the toggle editing followed by add point features. Now our cursor is changed to a target sign. Click on the topo sheet where you want to add the points. I want to store this Paioli as a city name. So I will click on here. Now we can see a pop-up window and this ID and CNAME are the field names which were created previously. We need to add these informations to create the point. I will enter ID as 1 and city name as Paioli and click on OK. Now we can see a point is created here. I am going to add another city name as Maladi. I clicked on here and entered ID as 2 and the city name as Maladi. Click on OK. Again another point is created over here. When you have added enough points, click on the Save Layer Edits button to save the data and toggle Edit button to stop the editing. Now we can check the attribute table of our point data. Here we can see the entered information. Close the attribute table. Next we will learn how to create a line vector data. For that, go to the layers, click on create layer followed by new shapefile. Click on browse button to specify the location for the saved data. Enter the file name. Here I am giving road underscore name as I am going to digitize the road features. Click on save. Select the geometry type as line. Click on select CRS button and define the WGS80 for UTM zone 43. Select the WGS80 for UTM zone 43 north from the recently used coordinate reference system. Click on OK. In the new field, enter the name as road underscore name. Select the type as text data and define the length as 50. Click on add to field list followed by OK. Now we can see that the layer is added into the layer panel. To digitize the features, select the layer and click on toggle editing followed by add line feature. Now start digitizing the road from the topo sheet by clicking on the road. Every click will create a vertex which helps to change the direction of the digitization. To move the topo sheets on the canvas, use the arrow key from the keyboard. If you digitize wrongly, you want to go back, use the backspace key on the keyboard to remove the vertex. Use the scroll button on the mouse to zoom in or out while digitization. To stop the digitization, right click on the canvas. Enter the ID as 1 and road name as Kozhikode, Malappuram NH. Click on OK. After digitization, click on Save Edits button to save the edits and toggle edits to stop the editing. Uncheck the topo sheets from the layer panel to see the digitized road and city name. Now we can see the digitized road and the city name. Check the topo sheet to see the topo sheet on the canvas again. Now we will create a polygon vector data by digitizing the water body from the topo sheet. Go to the layer menu, click on create layer followed by new shapefile layer. Click on browse button to specify the locations and enter the name here. I will give the name as water body. Click on save. Select the geometry type as polygon. Click on select CRS button and select the WGS84 UTM zone 43 north from the recently used coordinate reference system. Click on OK. Enter the field name or column name as water body underscore name. Type is text data and define the length as 30. Click on add to field list, followed by click on OK. To digitize the water body, select the water body layer, click on toggle edit, followed by click on add polygon feature. Now we can start digitizing the water body. Here I am digitizing the water body roughly. To finalize the digitization, click on right button. Enter the ID as 1 and the water body name as ClearIDU, which is not the exact name of this water body. For the training purpose, I am showing an example. Click on OK to create the feature. Click on the toggle edit button to save the edits. Now we have created 3 types of vector data, that is point, line and polygon. As this symbol depicts the type of data, that is point, this line and this polygon. Now we will save this entire project by clicking the project menu, followed by click on save. Specify the location where you want to save the project and enter the project name. Here I am giving training project. Click on save to save the project. Now we can see that our project is saved as training underscore project name. That's about this section. In next section we will learn different types of file extensions.